We definitely need to implement structural health monitoring, especially for high seismicity areas. That will definitely help construction industry to be more sustainable and also save our natural resources. That will address design for longevity. We can extend the lifespan of our structures by using monitoring.
Kia ora, I'm Troy, HERA's Chief Executive, and welcome to Stirring the Pot. Thanks for connecting. If you're new, here's what you can expect. We're going to be talking the tough stuff, the things that keep us middle minds up at night. There are many challenges facing our industry and equally many opinions on how we should tackle them. Stirring the Pot provides a facilitated forum to discuss and challenge these viewpoints.
So let's get to the nuts and bolts of it. Today we're having a kōrero with 𝗂𝗵𝗃𝗵𝗃𝗵, who's the project lead for the theme of Monitoring 4.0 in the Endeavour Funded and HERA-led Ngākopa Construction 4.0 research project.
Monitoring 4.0, it's one of the project themes in the Ngākopa Construction 4.0 rangahau research. Wondered if you could just explain what exactly Monitoring 4.0 is.
Monitoring 4.0 refers to structural health monitoring, which will use the Construction 4.0 technologies to better implement the structural health monitoring concepts and provide more useful information about buildings and infrastructure.
And so how does that connect into the Construction 4.0 research that you're doing?
Actually, Monitoring 4.0 is a foundation of Construction 4.0. If we look at the objectives of Construction 4.0, that is, we want to increase safety and productivity, and also we want to make construction more sustainable, then Monitoring 4.0 is exactly the solution. For example, by doing Monitoring 4.0, you can detect the early damages in bridges or buildings or infrastructure, and you can plan to repair it before escalating the damage. So by doing so means that Monitoring 4.0 will help construction industry to develop low-cost repair and avoid replacement and rebuild buildings and infrastructure.
So currently, when we are looking at understanding the structure and how it may be impacted by different forces such as earthquakes and things like that, how are we currently trying to understand how buildings are reacting versus the possibilities of Monitoring 4.0?
You know, at the moment, it is really limited viable solutions to understand the response of the buildings or structures to earthquakes or other types of loadings. Basically, you know, the prediction of the performance is a theoretical, which has been developed based on some experimental testing, but those experimental testing, they only limited to, you know, testing on components of the buildings or part of the buildings is really limited full-scale testing. So I can give you an example. For example, 𝗂𝗄𝗵𝗃𝗵𝗃 published a guideline on assessment of the buildings, which will use, engineers will use it currently for assessment and design for retrofit of the buildings. But there are many assumptions, you know, and all equations and assessment methodology is a theoretical methodology that engineers will follow, needs to make many assumptions, and based on that assumptions will provide, you know, conclusion about the current situation of the building, and also that will be a basis to predict the future performance in earthquakes. So I think what is game changer regarding the using Monitoring 4.0, Monitoring 4.0 will give you exactly the right answer without need to assumption, will give you the right current situation based on the real situation, the current, health of the building.
So what I'm hearing from that then is that it may lead to, I guess, less conservative approaches.
Definitely.
And will inform projects better. So I know that in some cases, for example, we're using shape table experimental testing at the moment to understand, but there are some limitations to that. Do you think you could sort of help understand what those differences between the experimental testing and monitoring 4.0 might be, and what that would mean for, I guess, industry in terms of perhaps cost savings or productivity?
Yeah. Back to your first point regarding the using monitoring 4.0 will lead to less conservative. Definitely, when you do assessment based on assumptions, then the results could be unsafe or very conservative, depending how your assumptions are really far from the real parameters. Construction monitoring 4.0 exactly addressed that issue. And, in structural engineering research, the most viable and reliable methodology is experimental testing. And full-scale experimental testing is the best. But the only or the best methodology to do full-scale is for seismic assessment or seismic performance prediction is a shaking table test. What does shaking table test mean? Basically, there is a platform which building needs to be built on that table, on that platform, and that will be on the artificial earthquakes. There are a very few shaking table tests that can test the full-scale buildings. There is a real limitation. For example, in U.S. San Diego, University of U.S. San Diego, that they have one of the largest shaking table tests. They could, a few years ago, they could test 7-story steel and concrete building. And just recently, they tested 10-story hybrid building, hybrid timber, steel, concrete building. So it's really, really real limitation here. And when we talk about shaking table test, still it is not a full-scale real testing because the building is not on the earth. It is on the table, on a platform. So you cannot see soil structure interaction. So there are many parameters that we will miss when we use shaking table test. Earthquakes would be artificial earthquakes, will not be real earthquakes. So what is the solution? The only solution is a structural health monitoring, because by using structural health monitoring, you will instrument a real building in a real situation, and if you have enough sensors and do proper post-processing, then the results would be exactly like a full-scale or even better than full-scale testing, because you are testing the real building on the real ground, on the real earthquake or loading. And that will give you invaluable information that never tests or any other type of the research can give you.
So this does apply to a building having to be already constructed. So how does that work in terms of informing other buildings? You would just apply the sort of learnings from that particular building to similar ones in the area? Is that the idea of it?
Yeah, if you repeat and use structural health monitoring for different types of buildings, and for example, for one building, if you do monitoring in every few years, like exactly after construction, and then every few years, then that information will give you insights how, for example, building form over the time, and that will provide very useful information, back to design and construction. And mainly to design, because our design mainly impact the performance of the building, but maybe also to construction as well. Sometimes, construction methodology may impact the building performance. So by using monitoring 4.0 and by increasing number of buildings that we measure and monitor, we will be able to give feedback to design and construction. And that will can change our standards and building code as well. I believe our standards are in some areas are really conservative, and we have to be conservative because in lack of full-scale experimental testing, there are lots of unknowns that we have to be conservative. But when regularly we implement monitoring 4.0 and test our buildings in a current situation and we monitor the deterioration, etc., then we will be able to have a more circular information, and that will lead to less conservative approach.
Nice one. It seems like a really exciting approach, and I do know that you have been working on some actual case studies and using some buildings to place monitoring in. Can you just share a little bit about that experience and how you found that process of setting up the sensors and doing that testing?
Yeah, it was really exciting to use the monitoring in a real building. It was a 5-story office building in Christchurch. The monitoring took a few days. One day we installed the sensors, and then we left the sensors and that bug collection system for a few days. And then we collected the sensors dark one day. So less than 1 week, we measured the building, and the sensors, which we used accelerometers, they can record very small accelerations, like in a magnitude of micro g. So even when people walking in the building, the vibration will be enough to be detected by accelerometers. And by post-processing, which took few months for post-processing the data, all model parameters of the building were identified. So like, for example, natural period, mode shapes, and even elastic stiffness. So it was really interesting when we compared the results with the model. We could see that how our modeling and engineering and judgment and compared to the real measured data. For that building, definitely the design was safe, but we could see that maybe a bit conservative, which again, I believe that's not a design problem. It's our design code and standards. So that's why that I'm saying that by regularly using monitoring and increasing number of buildings for different types of buildings and other structures, we will be able to provide more realistic prediction of the performance, and we can reduce our safety factors to be less conservative. And again, when you are less conservative in design, means that less materials will be used in construction, and that's again would be more sustainable approach.
Yes, I get that. It sounds to be that it just seems like a no-brainer really to use this kind of technology. So what would that look like, I guess, in the future of construction? I mean, do you see it as something that every standard building should have these sensors just in place as part of the design? How do you see this playing out in the future of construction in terms of integrating this into design?
We definitely need to implement structural health monitoring, especially for areas like high seismicity areas, like many regions in New Zealand. We need structural health monitoring. So that will definitely help construction industry to be more sustainable, and also we could save our resources, natural resources, that will address, design for longevity. We can extend the lifespan of our structures by using monitoring. So it is something that we definitely will need it. But in terms of, the methodology, we have two types of monitoring. One is permanent monitoring or continuous monitoring, which probably needs more investment from asset owners to install the sensors, make sure that they will be maintained over lifetime, and then develop, programming and coding to automatically process the data and give the information. So that needs investment and wouldn't be cheap option. But another option is a temporary monitoring, which probably is very cost effective, and exactly what we are doing in this research is a temporary monitoring. We will install buildings on a building for a few days, collect data, and will provide the information. So both options will provide great information. I believe for more important buildings, we need continuous permanent monitoring installed on the building. We make sure that we don't miss any, important deterioration of the building or any material events, like, for example, a medium earthquake, for example, and make sure that we will monitor continuously the building or, other structures. But for other buildings, temporary monitoring can work very well.
And what would you say in terms of using Monitoring 4.0, given how effective it seems to be in terms of informing design and construction processes, what seems to be the barriers that is stopping that from being adopted currently that you can see, and how do you think we could probably overcome those?
I think probably from global perspective, it is an area which currently is very research area, emerging area. Still lots of research is ongoing to develop a better solution, to reduce cost, to gain a more valuable information, So there are some research and knowledge gap that research needs to solve it. However, whatever have been developed so far will be able to give us information that we require, but in some cases may be really expensive, very expensive. So that means that we need research to make it more like cost-effective option to ensure that, everyone can use it. Another problem is, the mindset of asset owners. Many people don't want to expose their buildings and assets. They feel that, by using monitoring or even temporary monitoring, their buildings will be exposed to public, and then that may, affect the value of the asset if anything like any damage can be detected. But that's a wrong perception, actually. I believe, as I mentioned, by early identification of the damage, the right solution at the right time can be developed, and the building repair would be cost effective before escalating the damage. And in some cases, when really the damage is escalating, there is no any other choice rather than rebuild, demolishing and rebuild. So I believe this perception needs to be changed. And here, regulation can actually play a critical role, because in New Zealand, we need to put in our regulatory framework and make it mandatory for some buildings and important structures.
So I guess going into that, what jurisdictions already require this as part of their building regulation?
In high-seismicity countries, in many high-seismicity countries, there is a mandatory regulations for monitoring 4.0. For example, in the US, California mandated monitoring for every building 10-story or above or buildings with, lower than 10-story, but with floor area exceed a limit. I don't remember the details, but definitely California is one of the states in the US that mandate structural health monitoring for buildings, conditioned to some limitations. I think there are some states in the US that they are thinking about mandating the monitoring. In Chile, there is mandatory regulation. Japan is another country. China in high seismicity areas. And there are some other countries that for important buildings, they will do monitoring.
Yes, it does sound like that regulatory support is really crucial in ensuring that areas, particularly that are going to have potential issues, are being really proactive rather than reactive post-event. They're really trying to understand what's happening with those buildings. So like you can say, they can fix those issues before they actually become bigger than they potentially could be. So it just seems like a bit of a no-brainer really, doesn't it? And you did mention earlier on, you were talking from a global perspective, what's happening around there and that it's really in its nascence. What is the state of the art globally then?
I think globally, structural health monitoring from research perspective has taken critical steps. Compared to 20 years ago, now structural health monitoring is really provided real solutions, and it's, amazing solution from technical perspective. If you look at what monitoring can provide, is really invaluable information. As I mentioned, still some gaps exist. For example, now we are in a time that AI will change and shape everything, including construction. So there are research in monitoring how AI can be implemented to make monitoring more cost-effective and to provide more information. So in terms of research, I believe structural health monitoring is one of the most interesting and able research area in structural health monitoring, in structural engineering in general.
Yes, I definitely remember when I first heard the concept of monitoring 4.0 and it was being explained to me, it kind of went right over my head. And I think sometimes that's the scary thing about Industry 4.0, Construction 4.0. People are hearing that it's going to be changing the way that we do work or do construction, but aren't quite understanding those technologies very well. And as you say, things like AI is really becoming quite mainstream. Even in every day, we don't even realise that we're engaging with these technologies. So I guess for the steel industry in Aotearoa and our members, what would you say are the things about monitoring 4.0 that are going to help them to do construction better?
By doing monitoring and implementing monitoring, first we will be able to provide information that there is no other solution or way to provide that information. So that invaluable solution will give us better understanding the performance of our steel structures. And by having that information, first step would be, revising our design methodology and also maybe construction methodology. So then by implementing monitoring more widely, we will be able to manage infrastructure more effectively. And so by, real-time monitoring of our asset, the whole construction could be more productive and address any issues on time and very cost effectively. So I believe it will really, monitoring 4.0 will give us opportunity to be more realistic, less conservative, and provide a technical solution that even currently could be cost effective, but in the future definitely will be more cost effective, that currently we don't have any other solution to provide such information. So I think my point here is, let's implement monitoring 4.0 in a larger scale.
So there you go. Thanks for joining our conversation with Kaveh today. If you'd like to connect more with him, you'll find his details in the show notes. At the end of the day, Monitoring 4.0 is all about empowering the construction sector with real-time insights. It's not just about reacting, it's about being proactive so that we can act at the right time to build smarter, safer, and more sustainable structures. Food for thought till we see you next time. So hit subscribe, and if you liked what you heard today, please like, review, or share with any metal minds you know. Let's spread the word. This podcast features researchers who are part of the HERA-led international collaboration through a $10.3 million Endeavour funding grant to optimise the construction process. A year into this research and some major headway has been made. We are close to releasing the first book publication, Ngākopa Construction 4.0, which explores why Construction 4.0 in Aotearoa makes sense, sharing insights and integrated connections across the core themes of the research. This will be a valuable resource for those interested in the future of construction and wanting to make the journey towards implementing Construction 4.0. We are now taking pre-order requests for this book. You'll find the details in the show notes.